Hello everyone, I'm Xiao Gang. In the last lesson, we demonstrated binding the health bar. You probably found it quite annoying to write, because you have to bind the delegate and then unbind it, right? So, is there a way to make it simpler to write without considering performance cost? Of course there is. Let's go to this folder and start writing some UI since we haven't written an UI before, right? As for this UI, how do we do it? Right here, let's first create two, because we might need them later. Let's first create two. Then, for this UI, we need to write a common UI, meaning all our UIs will inherit from it, because this makes it easier for us to implement some common methods, just like our ability. The game ability, we write some common methods, so that all our UI components can benefit from them. Okay, then over here, in the character info section, within this UI, inside character info, we will place two more. There's no room here. We'll just stick it here. This means we are going to use C++ to write our UI. And as for the name, I will call it character UI info.r cpp. Now let's refresh the project. Okay. Then we come to this. Let's first write our base class. Note, we use, because we need to use, so generally we need to include this MG module, and we usually also include a slate and slate code. Okay, because when we write UMG, sometimes we write slate, because the underlying layer of UMG is slate. First, let's include the header file. Right, and here we include our URJIT. It's this one. This is the URJIT we often inherit in Blueprint. Then include this reflection file. At the same time, we made two forward declarations earlier. Okay, so this character base is our character base class. This widget animation is on UMG. We opened an animation because sometimes we might, at the C++ level, also want to play animations. We might need to have this feed because maybe not everyone knows how to get this animation in C++, since through Blueprints. In its unit graph, it's very easy to get. So we just wrote it here and then here. I direct output calcoic. It's relatively simple. That is, we inherited this widget, and this is our control, right? This is ours. These inverted red ones. Then on our side, first check this to function creation. Actually, if you are new, you will find this place was originally empty because we copied this. When it is created, it will also include this for you. That's pretty good too. Then let's adjust it like this. The parameterized check inside the attachment expires. Okay. Then let's write this method. This method takes a name and can retrieve the corresponding animation. This method is a bit complex. How is it written? It is written like this. First, it goes like this. It gets its get class. We used static class before. In static class, it is clearly a static method, and get class. It is inside the object base. It is a method that requires an object to be instantiated to obtain its class object. Then we convert it to this. We get brought to genetic class. That is equivalent to converting it to this blueprint class. That's what it means. For a blueprint class, it certainly inherits from this class. That should be what it means. This uClass object, it is such a class because we are ourselves. We are widget. So our get class returns the. Then through this blueprint class, we can use this method to retrieve all of its methods. All of this animation, all animations. This animation is the one you keyed in the blueprint. Here we include the header file. For the header file, including these should be enough. This is also relatively simple. That is the position inside our character and the position within this blueprint. You can see it here. Right here, you can see there are some comments in other places. Right. Then after we obtain all these methods, because it is a Tarmac train, we use what we learned earlier in chapter 4, that find by predicate, to check if this name matches the name of the animation passed into this widget. But note that an instance suffix needs to be added later, possibly here. If it is slightly different here, you might compare it. Take a look at the font, all the animation names, and check. Here it is a pointer to a pointer. Because we explained earlier, that fighter prick, it returns to point to, a pointer inside the host element. Because the elements in your host are also pointers, so it is a pointer to a pointer. Okay, if it can be found here, we can just return it here. And here we need to dereference once. And here we need to add a semicolon. Take a look. There should be another bracket here. Because in this part, public list is passed. So having another bracket here is correct. Okay, so this allows us to get the corresponding animation. As for playing this animation, we can just call this method directly. If we can get the animation, we don't need to use play animation. Obviously, this play animation is the method in our play, the method in your widget to play the animation. Right, okay. Basically, after this preference, let's take another look. We also need to get our character. As for the character here, first of all, we usually get it through getWorld. GetWorld can generally be obtained because you instantiate it in the world. After instantiation, we directly go through the player's controller to get the first local player's controller, and then the pawn it controls. Then we just return it. Okay, let's compile it first. Make sure the compilation passes. As for this animation, later on, for everyone, we will create a rising and fading animation for the damage value. A quick keyframe will make it clear to everyone. So let's put this code here for now. Then next, we mainly need to write our character info. This time, for character info, we will have it retrieve data in real time. And with this approach, it means that when we create the blueprint later, we won't need to write its blueprint event graph. We will implement its logic directly at the C++ level. Our blueprint only binds its, what is this called? Space is enough, and this place contains its files. Because our build for S here has already retrieved this path. Right, that is this path here. That is, we have this core path. So here we can actually directly include it. And remember to include the reflection file. Then we forward declare it. This is our text box. Right, then I'll just go ahead and expand it directly. Expand it to show everyone. It's quite simple. So obviously, this place is a text box. It displays the corresponding texts, what they look like. So the red here means you need to go into the blueprint space to bound the wait gate. That is, your blueprint space must have this space. Only then will it work. If it doesn't, you'll get a compilation error. That's roughly what it means. And here we have 3 functions. The last 3 functions are all written. Many friends might say, what do these 3 functions do? You can understand them as equivalent to begin play, tick, and end play. Why aren't they called begin play, tick, and end play? Because it's a U class. Because a class inherits from actor. So it's called begin play, end play, and tick. And for U class, this thing inherits from chair. That is to say, you can't the methods it overrides are actually overriding these methods in Urvigate. Of course, this code is quite extensive. Anyway, let's find it for Gaga. It should be fine. Let's jump back. We jump to its parent class. Okay. It's overridden right here. You see. Okay. Then this is actually those methods in our blueprint. Okay, then let's override these methods. Okay, there is a detail here. That is, you absolutely must. The things I deliberately emphasize here. You absolutely must know. This place must remove the negative class. If you don't remove the negative class, serious problems will occur. That is to say, you don't know why your code doesn't execute after you write it. And you'll find that no matter how you check, you can't find it. That is, if you don't remove this negative class. Okay, so now that we have a widget initStick function, how do we do it? First, let's include the same file. Let me explain these files to everyone. These 3 things go without saying. This is the ASC character class we wrote ourselves, and our attribute set. Then this components is the text box pointing to this blueprint. Okay, the text box on the monthly screen. First, through our parent class function, we must obtain this actor. After obtaining the actor, we must obtain this within the RC. Then obtain this A, D. These two will definitely succeed. Okay, why will it definitely succeed? Because we, as players, look at him. Most of the time, there is a pawn. If he doesn't have one, we might need to do some special handling. But at this point, we only consider the case where he will definitely succeed. Then, through this line of code, we retrieve its attribute set. Right. I should test this again. It shouldn't be too troublesome. It's just passing a class object through ASE. Then it uses the class object to find the instance of this attribute set. Okay. Then we need to check here. Because this is a pointer, you might not have found it. To avoid errors, we check here. If this MG object exists, meaning it is present, call current property. After retrieving the property, we concatenate it. Why do we handle it this way? Because this thing can have a situation where it might have many decimal places. Sometimes we may need 0.4 to process it. This place, after processing is complete, we set it to just set it to txt. Sometimes we will be in blueprint. We will have floating points. For example, 0.1.02, and it often becomes 1.02, 0.0000. At this point, we may need to truncate it to keep the decimal places, not too many. This kind of situation can be handled. Doublets are handled by specialized nodes. In C++, can also handle them. Sometimes you can take a look. This is relatively simple. We won't go over it again. Similarly, in this place, if we do the health, then we similarly take these and we fetch them every frame, this matter and such. These are all relatively simple. Don't be fooled by how much is written here. Actually, it's all the same pattern. Just pay attention when you paste things here. Make sure to match them up correctly. Good. We finished this part. Now let's compile it. It should be fine. You don't need to worry about this comment. This copy doesn't matter. That's all there is to it. This tick mainly executes on the client side because only our client uses this. Only then does it have this UMG. So on the client side, it's fine to consume a bit of this resource because the impact is minimal. Now let's launch it. Good, we've opened it here. Then as before, come to our place here. Remember to turn off the new recording here. Then we are here. Open it like this into info. We find vid. Then here, we select our character info. Okay, after selecting it, we give it a VBP. Then give it character. Okay, call it character info. And then this blueprint. We double click to open it. After opening it, it definitely has issues. After you compile, it will prompt you. Because we need to have this. We need these blueprints to proceed. So I'll just paste it directly. Because you can also do it like this. Because this thing is too very simple. It's this UI thing. We don't need to worry about it. We'll just do it like this. Just this block. Okay. As for this UI, how do you actually write it? Very simple. You just pull out a size box. Then this place. Let's compile it again. And it will be fine. Then this place. It is not a variable. But this health, it is the health mana here. It can automatically bind to this process. There is a binary get here. And this type also matches. You can say, so the X here, the part in front is its name. You can see it's this name. This name must be properly bound. So we've written it like this. After writing it, you don't need to write anything here. You can say, right, these functions are quite friendly. We don't need to write anything here at all. You can delete it. Delete it? Okay, we'll leave it alone. Then after that, we'll take this thing, add it to our main UI. Note that it starts with VBP. Those starting with UI won't work. It must start with VBP because you actually wrote this widget in the VBP. Then let's adjust this here. Then we'll stuff it into the content. And over here, we'll set the anchor point and so on. Then we'll replace these. And I personally like to adjust this. Okay, place it like this, in this position. It might block a little bit, but it shouldn't be a big problem. Okay, then at this point, we launch our project again. Then we start a client first. Then we check if this value is normal. You will find that this value matches ours. And if it takes damage, can it respond properly? Let's test it again. We have two panels on the side, right? You can see it's completely okay, right? You see, the whole thing matches up. Of course, when I attack it here, it's the same. You can see. Okay, then let's stop here for this lesson. Thank you, everyone.